I was recently talking to a clean energy entrepreneur in Mumbai, and he just beaming with pride. He points to this glossy brochure for a massive new solar farm, funded by India's multi-billion-dollar PLI scheme. Finally, he said, we're cutting the cord. No more reliance on the North. Everything you see here is the future of a self-reliant India. He spoke with this real fervor. Like, he believed a government subsidy was a magic wand that could conjure an entire industrial ecosystem overnight. To him, the local content requirement wasn't just some policy. It was a patriotic shield. But then as we walked through the actual staging area, the whole atmosphere just shifted. I noticed this row of high-efficiency inverters and specialized silicon wafers sitting under a tarp. So I asked about the local supplier for those specific components. And his enthusiasm didn't just dip, it curdled. It turned into this kind of defensive irritation. He admitted, in a lowered voice, that the local components were either 3 times the price or that simply didn't exist at the scale they needed. And then he launches into this heated rant about how unfair it was that China could produce them so cheaply, calling it predatory pricing that had to be stopped at any cost. It was such a jarring pivot. One minute, he's the champion of a new industrial dawn, and the next, he's calling for more walls, more tariffs, more protection. He seemed completely oblivious to the irony of it all. While he was shouting about unfairness, it was actually China that was heading to the WTO, using the West's own legal playbook to demand that India play by the rules of open competition. That sudden shift from the bravado of self-reliance to the anger of being outcompeted, it's more than just a trade dispute. It's a window into a much deeper civilizational crisis. Really makes you wonder, can a nation actually decree its way into becoming a superpower, or is this solar skirmish just the first sign that the physical foundations of power have already shifted somewhere else entirely?
That anecdote it's just the perfect microcosm of the massive global tension we are diving into today. And it reveals this really critical disconnect. The core question before us is exactly that. Whether a nation, be it India, the US, or the EU, can simply, decree its way into superpower status through political policy alone, through incentives like the production-linked incentive, the PLI, or by enforcing a local content requirement, or, on the other hand, if the physical reality, the deep structural foundations of the industrial supply chain has already predetermined who holds economic and geopolitical power. Our mission today is to dive deep into this intersection. We're looking at how industrial efficiency, the immense complexities of global trade law, and the new national strategies being adopted worldwide are reshaping the global economic order. We need to look beyond the political headlines, beyond the tariffs and subsidies, and really focus on the structural realities of manufacturing, particularly in these foundational high-tech areas like clean energy and critical infrastructure. The strategic evolution we're seeing unfold globally is about much more than just trade deficits. It's about the underlying physical foundations that underpin modern national sovereignty. This deep dive is going to reveal how the mastery of the real economy is defining the new global pecking order.
Okay, let's unpack this. The most surprising element of that Mumbai conversation for me was exactly that point. The nation often accused of flooding markets is, at the same time, leveraging the global trade rulebook to demand others play fair. That strategic evolution in trade law seems like the right place to start.
It is. It's a masterpiece of strategic economic statecraft, really. This evolution of China from a rule taker to a primary defender of the WTO framework shows how industrial efficiency and legal mastery are just completely reshaping the global trade order, especially against this rising tide of protectionist policies in South Asia and in the West.
So when they entered the WTO back in 2001, the global view was that they were the ultimate rules taker, right?
Absolutely. The assumption was that this massive new economy was integrating into a system largely designed and championed by Western powers, and that the system would, gradually force them to conform to these liberalized global norms.
And what we've seen is not conformity, but mastery. They learned the rules so well, they are now using them on offense.
Exactly. Their involvement in WTO disputes demonstrates this profound strategic evolution. By fully leveraging the dispute settlement mechanism, they've shifted their position from just being a recipient of complaints to being one of the most active participants in the entire system.
Can you give us the hard data on that? Because I think the common narrative still focuses almost exclusively on them being the defendant in these cases.
Right. And the data tells a much more nuanced story about system engagement. By November 2016, China had been a respondent, defending themselves against complaints in 37 WTO cases since they joined.
Okay.
And while that number is significant, the fact is that most of those cases were initiated after 2006. So it suggests that as their economy grew, friction with established partners just naturally increased. That's expected. But here's the critical pivot. They were simultaneously and very aggressively filing offensive complaints too. As of that time, China had initiated 13 offensive cases as a complainant.
And who are they targeting?
Almost exclusively the European Union and the USA. This shows real intent. They aren't passively waiting to be sued. They are proactively using the system to challenge measures taken by their biggest trade partners, especially when those measures look protectionist. In fact, in a set of 100 recent active WTO cases, China's overall caseload ranked third, right behind the perennial leaders, the EU and the USA.
So if they're that engaged, they're essentially arguing from a position of strength. They're positioning themselves as the true champions of the multilateral trade system, challenging anyone who deviates from the rules, even if those deviants are the very countries that wrote the rules in the first place.
That's precisely the legal argument, and what makes their strategy particularly effective is their whole approach to compliance. They recognized very early on that if you're going to engage with the system fully, you have to play ball when you lose a case. And as a general rule, China has complied faithfully with WTO rulings, and they've done so in a timely way. This is a point that's often just missed in the political critiques. In fact, their record of prompt compliance actually stands in stark contrast to the occasional, sometimes considerably delayed, or even outright refused compliance we've seen from other major WTO members.
Like what?
Well, think of cases like the EU's extended difficulty in fully implementing the ruling in the long-running EC hormones dispute, or certain instances where the USA has delayed action on panel findings. China's general commitment to implementing adverse rulings suggests a strategic intent to maintain the integrity of the system, even if they occasionally test its legal boundaries with the initial policies they enact.
That brings us to maybe the most sophisticated part of this legal mastery, the idea of buying time. If they know a measure probably won't hold up in the WTO, but they enact it anyway and then comply just before the hammer comes down, the whole legal process becomes a tactical economic tool. How does that buying time strategy actually play out?
This is where you see legal mastery used as a state-funded time subsidy for domestic industrial growth. It's fascinating. Academic case studies, particularly those analyzing specific trade measures, have found that China frequently terminated its WTO inconsistent measures, things like subsidies or local content requirements, just before the publication of the final panel reports that would force them to change.
So they get the benefit without taking the final hit.
Exactly. We saw clear instances of this in, for example, case DS-414, which concerned grain-oriented electrical steel, and in DS-440, which was related to certain auto parts. In these scenarios, the policy was in place long enough to achieve a specific domestic industrial goal, to gain market share, build capacity, or force domestic substitution. And then it was removed right before the final ruling, allowing them to claim timely compliance while having already reaped the economic benefit.
It's weaponizing due process. The procedural lag that's just inherent in the WTO, the time it takes for a complaint to be filed, investigated, ruled upon, and appealed, that can be, what, 2, 3, maybe 4 years?
It can. A huge window of protection for a nascent domestic industry.
Wow.
Exactly. What this pattern suggests is that the WTO dispute settlement mechanism has at times served as a deliberate tool to gain time for domestic industries to mature or to shift production methods before the final binding enforcement is due. They move from simply rules takers to rule defenders who understand the rulebook so well that they can use the inherent procedural delays strategically. And they use it against countries that are trying to use protectionist measures like the very local content requirement that started this whole thing in the first place.
So the strategy is critical to understanding the dynamic.
Yeah.
They demand open competition because they know the structural reality on the ground favors their existing industrial base.
That's the key.
Which ties the legal strategy directly back to our Mumbai entrepreneur's dilemma. China uses the law to keep the market open, knowing that their manufacturing is, for now, unbeatable on cost. It forces us to ask the really big question. Why is it so incredibly difficult for a nation like India or even the US to quickly replicate that manufacturing superiority, even with billions in government funding? What are the fundamental structural barriers?
That is the core linkage we have to understand. We have to move past this political narrative that high-tech manufacturing is simply a matter of political will or funding incentives. The irritation that the Mumbai entrepreneur expressed, about the high cost and low availability of local inverters and specialized wafers, that goes straight to the fundamental structural reasons why achieving self-reliance is an immensely difficult multi-decade proposition in high-tech sectors like solar and batteries.
Okay, so let's unpack the East Asian model's superiority. We often hear about cheap labor, But you're saying that's just the very surface of it. What are the deeper structural economic moats that make catching up so hard?
The real difficulty lies in capital, time, and most importantly, spatial organization. The physical location of the entire supply chain.
Spatial organization.
Yeah.
Right.
While it's true that established firms benefit from lower operating costs, labor, environmental compliance in certain regions, sure, the true, almost insurmountable economic moat comes from two integrated factors: economies of scale and geographic collocation. Mature operations realize these massive cost benefits because they're vertically integrated. They control the entire process from the raw material to the finished component, and they operate at a gargantuan scale that's been built up over decades.
Right.
This leads to significant proprietary long-term learning effects that are extremely difficult, if not impossible, to simply purchase or transfer to a new factory built across the globe.
So it's not just making a single component cheaply. It's about making every component cheaply and then seamlessly integrating them all together.
Exactly. And look at logistics efficiency. In these mature clusters, sequential parts of a complex supply chain, from refining raw materials like lithium or silicon to manufacturing cathode active materials for batteries or specialized solar cells, they're concentrated in these incredibly tight geographic clusters.
They're all in the same place.
This dramatic collocation reduces logistics costs immensely. You're not shipping sensitive, heavy materials across continents. They are literally moving across the street. And beyond the cost saving, this proximity enables much quicker material qualification and process improvement. If a batch of raw material has some issue, the feedback loop to the refining plant is immediate because the engineers and scientists are physically right there near the next stage of production. This acceleration of continuous improvement is something a geographically fragmented supply chain simply cannot replicate, no matter how much money you throw at it.
That makes the process sound less like a series of distinct factories and more like one unified giant chemical system.
Yeah.
You also mentioned a fascinating detail about efficiency relating to reagents and waste, the mastery of the industrial ecosystem.
This is where the cost advantage truly becomes overwhelming. We need to think of these operations as intensely symbiotic. By co-locating refining and cathode manufacturing near primary chemical plants, these operations secure guaranteed low-cost access to necessary reagents.
Okay.
And here's the genius part. These reagents may actually be waste products of other chemical processes happening right next door. So the waste stream of one operation becomes the feedstock for the next. Furthermore, the specialized waste byproducts from their own manufacturing, which in a fragmented, isolated plant would be a really expensive environmental disposal problem, can be easily monetized or recycled internally within the complex. This closed-loop efficiency, where the supply chain is treated as a single, massive, interlinked chemical system, provides a marginal cost advantage that a new entrant trying to build a single, isolated facility, like the one in Mumbai or a new U.S. gigafactory, simply cannot match. It eliminates disposal costs and raw material costs at the same time.
That just paints such a powerful picture of an entrenched systemic advantage built up over a very long time. So now let's contrast that with the practical reality facing new domestic entrants, say, in places like the U.S. If they try to build this from scratch, how high is that barrier to entry, specifically in terms of capital and time?
The barrier is astronomical, and it's why a local content requirement often fails politically. New battery projects in the U.S. are just significantly disadvantaged from the get-go. When we look at the total capital required to get a plant up and running, site acquisition, equipment purchase, construction projects can be anywhere from 2 to 7 times more expensive to build in the U.S. compared to other countries where that industrial ecosystem is already established.
2 to 7 times more expensive. That's a deal breaker for many private investors right there. What drives that staggering difference?
It's driven partly by higher capital costs, sure, but also critically by significantly slower project delivery timelines. In established manufacturing regions, especially those with mature, streamlined permitting and construction processes, a new facility can be built, commissioned, and operational in as little as 6 to 12 months.
6 to 12 months.
In the U.S., those timelines typically run multiple years, often 3 to 5 years, just due to regulatory hurdles, protracted permitting processes, community reviews, securing the necessary utility upgrades. You can build an entire multi-billion-dollar factory overseas in the time it takes the U.S. just to get the permits and complete the necessary civil work.
So the high cost is compounded by this incredible risk associated with a multi-year lag before you even see a potential return.
Exactly. And that brings us to the acute risk faced by those attempting a first-of-a-kind operation in a new domestic market. Since the domestic industry is starting from a limited foundation, these new operations often rely heavily on foreign engineering knowledge and equipment suppliers for the initial build. They face immense challenges not only in project delivery and commissioning, but in the critical stage of material qualification. To become a viable supplier, especially for complex components like the high-purity chemicals needed for electrode active material, a new domestic operation has to build a full-scale facility, incurring that huge upfront capital expense. But they may not see a single dollar of revenue for 12 to 18 months, while that qualification process with potential downstream customers, like a major automaker, is underway.
You have to prove it works at scale consistently before anyone buys it.
You do, and new, smaller entrants are extremely exposed during this period. They need substantial working capital just to survive this pre-revenue certification gap. That's why non-market actors, backed by patient state funding, can tolerate this high-risk, zero-revenue period much better than a private company trying to satisfy investors looking for quick returns.
So the problem isn't just making the product. It's proving you can make it at the right scale and cost, all while surviving that long, expensive path to customer acceptance. It completely reframes the US and European pivot from pure efficiency to resilience. It looks less like a choice and more like a necessary industrial defense mechanism against an entrenched, structurally superior incumbent.
It is.
That structural reality, the entrenched efficiency and the high cost of building new capacity, it really explains why focusing purely on efficiency led to such massive global concentration, putting all of our supply chains at risk. The global policy shift is now prioritizing resilience, redundancy, and diversification over just minimal costs. That's the core of the U.S. response, isn't it?
Absolutely. The U.S. government, recognizing this profound dependence, has launched a multi-pronged industrial strategy. The goal is to build a resilient energy sector industrial base, an ESIB, and to tackle that critical reliance on concentrated foreign sources, particularly in Asia. And this effort is not merely about writing big checks. It's about signaling long-term, sustained federal demand and investment to de-risk private capital.
Let's look at the solar sector first. Solar is crucial for decarbonization, but the U.S. market has been just overwhelmingly dominated by imported panels. What physical infrastructure are we actually seeing that's moving past the planning stage and into reality?
We've seen key legislative incentives, notably the 48C Advanced Energy Projects tax credit and the 45X production tax credit, which provides a direct subsidy based on output. And that's spurring genuine investment momentum. A powerful example is First Solar. They recently inaugurated a major $1.1 billion photovoltaic module manufacturing facility in Lawrence County, Alabama in 2024. This facility is massive and, combined with their existing Ohio plants, aims to create 11 gigawatts of vertically integrated solar manufacturing capacity right here in the U.S.
And the strategy is holistic, right? It's not just new manufacturing, it's the whole life cycle.
Exactly. It's about the circular economy, too. SolarCycle, for example, is investing $400 million in Georgia to construct what will be the country's largest solar panel recycling facility. This facility is projected to process between 25 and 30% of the total domestic retired solar panels by 2030, which is crucial for resource security. They are also building a $344 million solar glass plant, leveraging those same 48C and 45X credits, having secured initial partnerships with domestic manufacturers. So this demonstrates that the policy is working to anchor capacity at different interconnected points of the supply chain.
And the government is backing this up not just with incentives, but with its own massive purchasing power.
Precisely. The establishment of the Made in America Office, or MIAO, within the administration serves to ensure that federal dollars drive this domestic investment. They significantly strengthen the Buy American rules for federal procurement. The domestic content threshold has been increased from 55% to 65% this year, with an explicit plan to raise it further to 75% by 2029. This policy creates a guaranteed sustained demand signal, a crucial mechanism for offsetting that high, first-of-a-kind capital risk that can paralyze private investment without state backing. The federal government becomes the reliable anchor customer.
Okay, moving to batteries. The power source for EVs, for grid storage. The supply chain challenge there seems even more profound given the overwhelming concentration of foreign control over the midstream and upstream components like refined minerals and cathode materials. What's the tangible result of the announced investment in this sector?
The scale of investment has been transformative. Since 2021, over $150 billion has been announced for the U.S. battery supply chain, spanning everything from mining to recycling. This investment is creating a massive pipeline of new cell manufacturing projects that collectively offer over 1,100 gigawatt hours per year of capacity. That level of capacity is enough to supply anywhere between 11 and 17 million light-duty electric vehicles annually, which is a foundational shift in the industrial base. Federal funding, including large grants, loan commitments from the Loan Programs Office, and tax credits, accounts for over $33 billion of that direct investment. Moreover, the U.S. possesses a fundamental untapped advantage in critical mineral reserves, especially lithium. Analysis funded by the Department of Energy found lithium resources in Nevada that could contain more than 400 kilotons of the mineral. That's enough to support over 375 million EV batteries. And even more staggering, brine resources in southwestern Arkansas are estimated to hold between 5 and 19 million tons of lithium, which is enough to meet projected 2030 global world demand 9 times over. We're seeing a coordinated, all-of-the-above approach to extraction and processing to unlock these massive, economically competitive domestic resources, reducing that reliance on geopolitically sensitive sourcing.
So for renewable energy, solar, and batteries, the strategy is clear. Leverage domestic mineral wealth and unprecedented financial incentives to overcome the structural cost advantages of established players. But let's shift to the digital foundation. Information and communications technology, ICT, and semiconductors, these are perhaps the most vulnerable physical foundations of all.
They are absolutely critical. The geographic concentration of ICT component manufacturing in Asia poses systemic risks to virtually all global ICT supply chains. It threatens both economic activity and national security. Just consider printed circuit boards, or PCBs. These are the physical maps, the green boards, that enable all electronic functions from your smartphone to a fighter jet radar.
The basis for everything.
Everything. And over the last 25 years, the U.S. share of global PCB manufacturing has just plummeted. It's dropped from roughly 30% to just 5%. This massive consolidation represents a profound vulnerability across nearly every sector of the modern economy. If you can't rapidly build a secure, reliable PCB, you can't build secure communications equipment, defense platforms, or even next-generation vehicles.
So what are the major legislative tools aiming to reverse this decline in high-tech components?
The primary strategic responses involve the $52.7 billion SHICHI-PS Act for semiconductors and the Bipartisan Infrastructure Law, which dedicates $42.5 billion for broadband deployment. While the SHICHI-PS Act gets the most press for those leading-edge chip fabs, the infrastructure law is quietly driving manufacturing for the basic components needed for digital communication.
How does it do that?
It's done through the Broadband Equity, Access, and Deployment, or BEAD program. This program mandates that broadband equipment, including optical fiber, cable, and key electronics, must adhere to Buy America rules, meaning they have to be manufactured in the U.S. And this requirement is directly driving private investment. For example, Corning responded to this demand signal by announcing a $100 million investment to manufacture optical fiber and cable in Gilbert, Arizona. We are also seeing major equipment providers like Nokia partnering with U.S. manufacturers to produce Buy America-compliant networking products.
Let's dive a little deeper into semiconductors, specifically that distinction between leading-edge chips and what you called legacy chips. Why is the latter so important geopolitically?
Well, while the leading-edge chips, those measured in single-digit nanometers that power AI and advanced computing, get all the media attention, we have to focus on legacy chips, often called mature nodes. These are absolutely crucial for fundamental operations. They are the high-volume, highly standardized components that run our critical infrastructure. Automotive systems, older defense equipment, medical devices, basic telecommunications network.
Workhorses.
The absolute workhorses. And the reliance on these foundational components is acute, and the production capacity for them has become extremely concentrated. China has rapidly increased its global share of legacy logic production capacity from 20% in 2018 to 38% in 2024. And based on announced new fab projects, that share is projected to reach just over half of the world's capacity, 51% by 2029. This rapidly accelerating dominance in foundational, high-volume, low-cost components is a major geostrategic concern for any nation relying on robust critical infrastructure. It provides immense leverage over key global industries that cannot simply transition to advanced nodes.
This deep concentration risk is no longer theoretical, is it? It affects the most fundamental physical systems of a nation, how goods move and how a nation defends itself. We are really talking about the physical foundations of geopolitical power.
Let's look at the transportation industrial base first, focusing on maritime infrastructure.
The transportation sector is the circulatory system of the national and global economy. And during the era of peak efficiency, the U.S. allowed dependency on foreign sources to creep into even the most fundamental physical infrastructure. A prime example is port equipment, specifically those massive ship-to-shore, or STS, cranes that lift thousands of containers a day. These cranes are the bottleneck of modern maritime logistics.
Right.
And historically, the U.S. has moved aggressively to reverse this dependency on foreign manufactured port equipment. The U.S. Port Security Initiative represents a major policy response. It includes a substantial 25% tariff rate on STS cranes manufactured in specific foreign countries. But more importantly, the policy actively encourages supply chain diversification and onshoring. They're working with key international partners, like Japan's PaySeiko Corps, which is actively planning to onshore U.S. manufacturing capacity, and Finland's Konecranes, which is building a consortium of U.S. partners. This effort aims to bring port crane manufacturing capabilities back to the U.S. for the first time in 30 years.
30 years. 30 years without the capacity to build one of the most critical pieces of commercial infrastructure. That reliance on foreign sources for something so physically fundamental to trade, it just demonstrates the extent to which efficiency dictated national industrial structure.
And we learned the hard way the inflationary devastation that occurs when that efficiency fails and concentration leads to fragility. During the sharp global shocks of the COVID-19 crisis, high concentration in supply chains across multiple sectors led to extreme price volatility. Economic analysis demonstrated a very strong correlation. U.S. goods inflation tracked the movement of the Global Supply Chain Pressure Index, or GSCPI, closely, with a time delay of about 6 months.
And for our listeners, what exactly is the GSCPI?
It's essentially a single metric designed to track the various components of global supply chain health, things like global freight rates, tracking delivery times, and measuring order backlogs.
I see.
When supply chains were stressed, as the GSCPI showed by jumping to its highest ever recorded value in late 2021, inflation followed soon after, 6 months later. This crisis taught policymakers that resilience is not merely a security measure. It is a critical, systemic, anti-inflationary measure that stabilizes the cost of goods for the entire economy.
So if transportation bottlenecks affect consumer prices, then the state of the defense industrial base, the DIB, affects national security directly. What did years of focusing on just-in-time efficiency reveal about the DIB's vulnerabilities when stress finally hits?
The defense industrial base, much like the commercial sector, had increasingly shifted its operational model away from that traditional Cold War redundancy toward maximum efficiency. It was relying heavily on just-in-time inventory and global sourcing. The result was a DIB optimized for peacetime costs, but profoundly fragile under wartime or crisis-level stress. A critical illustration of this vulnerability is in the casting, forging, and machine tools sector, or CFMT. This is the industrial bedrock for virtually all large military hardware, from submarine hulls to armored vehicle parts. The fabrication of these complex, large metal parts moved overwhelmingly overseas, especially to countries that possess and operate immense foundries and produce steel at 4 times the U.S. production rate. This reliance on consolidated foreign sources for massive, irreplaceable components became a profound strategic liability.
How bad did the actual delays get for these essential components during the stress period of the pandemic and the subsequent global tensions?
The production and shipping delays were disastrous for defense planning. Lead times for large cast and forged components, the pieces that cannot simply be printed or substituted, surged dramatically. Lead times that were already measured in quarters suddenly spike to 2 or even 3 years.
2 to 3 years.
That's not just a delay, that's an entire ship or submarine program effectively put on ice for the duration of a presidential term while you're waiting for foundational parts. This revealed a massive gap between strategic ambition and industrial capacity. This is precisely why the Department of Defense released the first ever National Defense Industrial Strategy, or NDIS. It articulates a bold, decisive new vision, achieving a defense industrial ecosystem that is explicitly defined as dynamic, responsive, state-of-the-art, resilient, and a deterrent to our adversaries. The shift is absolute. The focus on efficiency is now explicitly subordinate to the necessity of resilience when the security of the nation is at stake. They are focused on increasing production capacity and strengthening supply chains in these critical areas, using tools like the Defense Production Act to prioritize efforts and mandate data collection.
The lesson across solar, batteries, chips, and defense just seems so clear. National capability is inherently linked to the mastery of heavy industry,
the physical components that cannot be easily air-shipped and substituted when the crunch finally hits. This deep dive really started with that moment of sharp tension in Mumbai, the clash between a nation's desire for self-reliance, expressed through policy like the PLI scheme, and the frustrating reality that high-tech industrial efficiency resides elsewhere, entrenched and protected by decades of investment and legal mastery. The great tension of modern geopolitics is precisely that conflict between political ambition, the decree of self-reliance, and industrial reality, the overwhelming efficiency of an integrated, highly scaled global supply chain.
And what the response from major economies around the world, the US, the EU, and others demonstrates is a profound shared realization that political ambition is ultimately meaningless without the underlying physical industrial capacity. The true foundation of national power has irrevocably shifted toward the physical mastery of the foundational economy. That means securing the raw materials, controlling the advanced components like legacy chips and PCBs, and building the resilient systems necessary to produce the goods that define the 21st century, whether that's EV batteries, solar modules, or next-generation defense equipment. The global competition for resilience, built piece by piece from the ground up, is now the ultimate measure of global influence, far outweighing the pronouncements of political policy.